Here are your notes for lesson 2, properties of isosceles and equilateral triangles. If you want to get the notes down on the top, hit pause real quick. I'm going to jump right into the examples. But like I said, the notes are filled in. I added to the picture just to show. Oops. Just to show that opposite the base angles are the equal sides and opposite the equal sides are the base angles. It can go either way. So these two sides are equal. Go across, those two angles are equal. Okay, first problem. Because these two base angles are equal, notice I drew an arrow across the opposite side. That tells me this side, marked it with a tick mark, is equal to this side. So we just need to set those two sides equal to each other. So we'll have 3w plus 14 is equal to 5w minus 6. I'm going to minus 3w from this side. And I'm going to add 6. So that this cancels out, this cancels out. And then we're left with 20 over here equals 2w divided by 2 divided by 2, and w equals 10. Okay, looking at the next problem. Common mistake is to look right here and say this is 90 degrees. It might be 90 degrees, but unless the box is there, I don't know it's 90, so I can't fill that in. So I got to look in the picture for other information. Again, we look at the big triangle. We have two equal sides. So if I go across from each equal side, go across right here, this angle, then if I go across all the way across the other side, and this angle are equal. So that tells me this is 25. This one is 25, and then this one's divided into 2. But what I can do is, because this is 25 and this is 25, those two added plus this one should add up to 180 because it's a triangle, or they do add up to 180. So I'm going to call this, I'm going to do 25 plus 25 plus, I'm just going to call it A. Okay. And we're going to set that equal to 180, and the A will be this whole angle across the top. So we get 50 over here plus A equals 180, minus 50 from both sides, and we get A equals 130. Now, if this whole thing is 130, and it's divided into two equal parts, or it's bisected, then we can take this 130 and we can divide it by 2 because it's two equal parts. And 130 divided by 2 would equal 65. So now we know this angle x here is 65 degrees. This side is also 65. I'm going to write my 65 degrees here. Now we can officially figure out what this or this angle is. If we look at the three angles of the smaller triangle, we have a 25 and a 65. So I'm going to come over here and I'm going to do 25 plus 65 plus y. And that should equal 180 because that's the triangle. 25 plus 65 is 90 plus y equals 180 minus 90 for both sides. We got y equals 90. So after all, even though it does look like 90, it is 90. Don't assume, though, just because it looks like it's 90 that it is. Alright, for letter C, we look and it says the perimeter of ABC is 37. I'm looking at the picture kind of trying to figure out what to do here. I see we have two base angles that are equal, which means the sides opposite each other are both equal, so this side is equal to that side. So we know this is 12.5. Now, if we know the perimeter of ABC is 37, we can do 12.5 plus 12.5 equals 25. And then if we take that away from the 37, that will give us what's left down here. So we do 37 minus 25, and that would equal 12. So we have 12 for the full distance across here, but it's asking for DC. So this is kind of a new rule. Whenever you have either an equilateral triangle or an isosceles triangle, and you drop down the altitude or the height, and it creates a 90 from the vertex angle. So if you look back up at your picture in the top right corner, the vertex angle is the angle between the two base angles, so or across from the two base angles. But when you drop that down, it splits this exactly in half. So these end up being equal pieces. So now if I know the total distance is 12, I can just divide it into 2. So we'll do 12 divided by 2 equals 6. Each one of these segments are 6, so DC then is 6. Alright, this is a nice easy one. As you can see, we have 2 equal sides. If I draw my arrows across, that would tell me this angle is equal to this angle. So I know y is 72 degrees. Now that I have that 72 and y is 72, I can subtract both of those from 180. So 72 plus 72 is 144. So I'm going to do 180 minus the 144, which are these two angles, and I get 36 degrees for angle x. Now if I wanted to check, let's make sure I actually have the right answer and I didn't just work through that too fast. I'm going to add up my three angles, 36, 72, and 72. 36 plus 72 plus 72, it equals 180, so I must have the right answer. Okay, real quick for example number 2. This says if a triangle is equilateral, then it is equiangular, and you can do that both ways. So if you have a triangle that is equiangular, it's also equilateral. In other words, if all three angles are equal, then all three sides are exactly equal. The way we can kind of prove that with what we did before is, if we're looking at this like a isosceles triangle, and we have two base angles that are equal, these two, that would always make these two sides equal. But there's a third side that's equal. So if I go across from that, then we get a third side that's equal. So it works both ways. And the measure of each angle is always going to be 60 degrees in an equiangular or an equilateral triangle. So example number 3, there's a little trick in this one. This says the figure is an equilateral triangle. So that means all sides are equal, but it also means every one of the angles are 60 degrees. So this is 60, that one's 60, and that one's 60. Now it's got a little catch in this problem. When you draw a line from the vertex back to the center of an equilateral triangle, what happens is it splits both of these angles in half. In other words, it bisects the 60. So we get 30 and 30, and 30 and 30, and 30 and 30 all around. So right by doing that, we just got ourselves y and w. Y and w are both 30 degrees. Now to get x, we just do 180 minus 30 minus 30 more. That would be minus 60. That would make x 120 degrees because this right here is a triangle within a triangle. The next one's a little bit of a puzzle here too again. They don't give you much information, or it doesn't appear like they do, but notice we have a 90 here, we have a 90 here, but we also have all three sides marked equal, so that means this bigger triangle is an equilateral triangle, so I already know right away then k is 60 degrees. If I ever forget that, by the way, I can do 180 divided by 1, 2, 3 angles. 180 divided by 3 would give me 60 degrees. Now from there, I'm going to write in all my 60s, because that's going to help me see where to go next. M down here I can't really get. It's not cut in half or anything, or at least I don't know it is. But up here on n, if I know the whole angle is 90 degrees, and I know that this piece outside is 60 degrees, I can do 90 minus 60 equals 30 degrees, and that would be my angle n. So right there I have a 30-degree angle right there. Now that I have 30 and 90, I can look at just the small triangle, and I can subtract 30 and 90 from 180. So I can do, or I can set up like an equation, do 30 plus 90 plus m equals 180. If you want just to subtract 120 from 180, that's going to be exactly what we're going to do. 30 plus 90 is 120. So if I subtract 120 from both sides, I will get m equals 60. So it looks like after all this was bisected here. M is 60 degrees. Alright, the final example in your notes. Alright, I'm looking for where to start here. If this is 60 and this is 60, what must this angle be? It must be 60 degrees. So now I have an equation here, because this angle is 60 degrees and it's 5x plus 8. I can do 60 equals 5x plus 8, because they're the same thing. Subtract 8 from both sides, and I get 52 equals 5x. And then I'm going to divide both sides by 5. It looks like I'm going to get a decimal. 52 divided by 5 is 10.4. So x equals 10.4. Remember, that's the value for x. It's not the total of that angle. So if we plugged 10.4 back in, we should get back to 60 degrees. Now for angle y, because this is equilateral, because of the three or equal angular, we know it's also equilateral, which means this side 70, this side is 70, and this side is 70. So we're going to set these two equations up just like we did the one down here. Now we're going to do 6y minus 2 equals 70 will be my one equation, and then my other equation will be 3z plus 7 equals 70, because that's the length of this side. We'll do this one first, and we'll come back to z. So first we'll add 2 to both sides, and we get 72, and 6y equals 72, so y would equal 12. We have to divide by 6. So y is 12. For this problem for z, we're going to minus 7, we get 63. We get 3z equals 63. If we divide both sides by 3, we'll get z equals 21.